Alright, so for number 3, it reads cotangent of theta equals square root of 5 with theta in quadrant 3. Find the exact values of the remaining trigonometric functions of theta. So this is going to reference the two videos that were assigned previous to this one. Alright, so we know cotangent of theta equals square root of 5. That immediately tells us that this is an answer to one of the 6 trigonometric functions. Let's find the other ones out. Since we know cotangent, we can immediately find out tangent, since tangent is just the reciprocal of this value. So tangent of theta is 1 over square root of 5. If we rationalize the denominator and multiply square root of 5 on both the bottom and the top, we get this answer and we're done. Alright, so I already found 2 of the 6 that I require. How do you find the other 4 trigonometric functions of this specific theta? Well, just remember that they're all defined in terms of sine and cosine. Because we're not going to be using a unit circle here, what we are going to use is this value. The reason why we're going to use this value is this value helps us create a right triangle for which we can find sine and cosine. And since we will be able to find out sine and cosine, we can find cosecant and secant thereafter. Alright, so how do you create a right triangle using these two values? Just remember, just remember that tangent, by definition, is opposite over adjacent. So if I take this as my reference angle, the opposite side is this one here, which is going to be 1. And the adjacent side is this side here, which is going to be square root of 5. And from that, we can find out the third side, or the hypotenuse, by using the fact that it's a right triangle. So a squared plus b squared equals c squared, and you get square root of 5 squared plus 1 squared equals question mark squared. 5 plus 1 equals question mark squared, so question mark is square root of 6. It should be plus or minus square root of 6, but a radius can't be negative. It's a distance, so the distance will be positive. So we know this is square root of 6. Now, as mentioned in the video, you can get the same value, however, using a different triangle on a unit circle. Because, sorry, not on a unit circle, but on a coordinate plane. It's a different color here. Because tangent of theta, as long as it is positive, we're okay with that. So this value here doesn't have to be positive. It could have been negative so long as the bottom value is also negative. Meaning I could have gotten the same tangent value using a different theta measure, namely this one, where this value is negative square root of 5 and this is negative 1. I would have still gotten this answer here, and therefore this answer right here using this second triangle. So which one is it? Which one am I looking for? Well, keep in mind that theta that we're looking for is in quadrant 3. So instead of looking at this radian measure, I'm rather looking at this radian measure. So we know that the first triangle, although it helps us with the values, is not the correct triangle we should be looking at. So we're going to be using this triangle instead. Alright, let's find out the sine and cosine values, and then we should be done. Sine, by definition, is going to be so katoa so, or opposite, over hypotenuse. So therefore, sine theta is going to be negative 1, since that's the opposite side, over the hypotenuse, which is square root of 6. And if we rationalize the denominator, we would get negative square root of 6 over 6. Whoa, sorry. since we know sine, we can get secant of theta by flipping over this value. Now it seems easier to flip this value instead of the second value, so I'll just flip this value instead, and I get negative square root of 6. Alright, let's find cosine of theta. Cosine of theta is, so ka toa, or adjacent, over hypotenuse. The adjacent side is negative square root of 5, the hypotenuse square root of 6. We're going to rationalize the denominator and get negative square root of 30 over 6. Again, to find its reciprocal function, or secant of theta, I'm not going to use this value, but rather this one, since it's easier to flip. Since if I flipped this value, I'm going to have to rationalize a denominator of 30, square root of 30, and then simplify the value. So here I'm just going to use this value since it's much easier to flip over. And we get negative square root of 6 over square root of 5, rationalize the denominator, and get negative square root of 30 over 5. And you're done. Alright, see you in part 3.